All right, here's the last piece that we're going to talk about in terms of population proportion, right? We've done our confidence intervals. Now we're going to talk about sample size for the population proportion, all right? So the sample size required to obtain this level of confidence for P with a margin of error E, same things we've been looking for, is given by this formula. N, right, sample size is always represented as N, P hat 1 minus P hat, and here's that critical value, Z of alpha divided by 2 over E, and then that quantity is squared. Now here's the key to this. You always round up to the next integer. It doesn't matter if it mathematically rounds or not. You always round up to the next integer. So for instance, if this was like 248.1, no problem. That's 249. All right. No matter what, you round up. So I want to make sure you make that point. And this Z alpha divided by 2 part right here, that is a critical value. And you're going to be given this critical value chart of Z alpha divided by 2. Okay. Now you can do this sample size in StatCrunch. There's a couple of things to do in StatCrunch that I think it makes it more difficult. I think the formula is easier to use, and that's why we're going to go ahead and just use the formula. All right. So this is with no prior sample. Okay. If this is unavailable. Okay. So let me try again. So given that you have a prior sample, you already know some information about your sample size. So you've already given information, then you use this first one. If the prior estimate is unavailable, so you don't have any information, this is brand new basically, and you get the sample size by N is equal to 0.25, and then the exact same thing, alpha divided by 2 divided by E, the quantity squared. Basically, if you have a prior estimate here or a prior proportion that you have, then put it in there. If you don't, we're just putting 0.25 in there. Again, round. You're always going to round up to the next integer no matter what, because the law of large numbers, right? This is saying here's the minimum you need. To pull this off, here's the minimum sample size needed. It's always best to have more. The more data you have, the more accurate you can be. Okay, so let's do a couple of these. An economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What sample size should be obtained if the economist wants an estimate within 2 percentage points of the true proportion with 90% confidence? All right. Remember, we said the word percentage. If it just had the word points right here, then error would equal 2. All right. If it is just the word points. This one, this one says percentage points. So whenever I'm looking at this margin of error, I'm going with 0.02 because of the word percentage. All right. And I'm going with 90% confidence. Now here's where that alpha divided by 2 situation comes in. If I am 90% confident, I come over to my chart. 90% confident, my value is 1.645. Literally, that's how that works. All right. So 90% confident, I know that this is going to be 1.645. All right. So the economist uses an already given estimate of 10%. So up here in my formulas, if I already have an estimate, I use this top one. If no estimate is given, then we use the bottom. But here with this 10%, I'm going to plug that in because that's my P hat, right? Okay, so I'm going to make this bigger so we can see it better on our screen. Here we go. N is equal to, and then I'm going to write this down since we can't see it. 1 minus P hat of Z alpha divided by 2 over E, the quantity squared. Let's plug that in. P hat here, we learned, is 0.10. 1 minus 1.10, 1.645, because we got that from our chart. That's at alpha divided by 2. And our margin of error, because it says percentage, is a decimal. And then that's squared. So plug that into your handy dandy calculator. What do you get? 608.8, and that's always, no matter what, even if it doesn't, it will, rounds up to 609. You always go to the next one. Therefore, the economist must survey 609 randomly selected residents of the U.S. $609, because you always round up no matter what, right? That's assuming that I have a prior estimate. Well, what if we don't? We do not use any prior estimates. Okay, how do you think that's going to work? Do you think it's going to make it bigger or smaller? All right, so hang on to that, and then let's check this out. So, again, my margin of error is 0.02, but n is equal to 0.25. I don't have a p-hat here, but I have alpha divided by 2 over e squared. So, n is 0.25. And now I'm still at 90% confidence, so I'm 1.645 over 0.02. My margin of error is the same. I'll scoot this up just a little bit so we can see it all. And then what do you get when you plug that in? 1,691.2, which means we're actually using 1,692. Yeah, because you always round up no matter what, right? So therefore, the economist must survey 1,692 randomly selected U.S. residents. Man, you can tell my handwriting is getting worse and worse. Okay. Now, why do you think? So we talked about it. Do you think it's going to be bigger or smaller? This one's way bigger, right? Why do you think that is? Yeah. Here, I've already gone through the process once. I've already gone through the process, and I'm just shoring up that process. So if I want additional data, I've already had a bunch of data, and that's how I got this to begin with. Here, I'm saying I don't have any data at all. I don't have anything that I'm working with here. If I have nothing to work with, then we have to make that happen. And the more you can survey, the more accurate your data is. And that's why it takes more. Here, if you're like, oh, I've already done through this. Well, let's do a little bit more in order to figure this out. All right. Hey, I got nothing down here below. And, oh, well, then we've got to start from scratch. And we've got a whole lot of work to do. It's basically how that plays out. All right. Nice. Great job, guys. Great job. See how we're using this previous? We just keep building. It's kind of exciting. I love this. I know you're just as excited as me.